Yeah, so you're being recorded live. You'll show up on Twitter. Generally, we send a week, maybe a few hours to a week. If you don't like that, bail out now. Otherwise, this is your permission to, you can be recorded and thrown up on a YouTube video. This is Coffee Compiler Club, anything to do with compilers, language runtimes, garbage collection, typing systems, concurrency, language implementations, all fair game. I reserve the right to moderate, never had to do it. Open mic, ask questions, conversation goes where it goes. I have a little bit of status. I sometimes dump at the start of the meeting, I'll do it here. And then otherwise, you know, people do what they do. Yeah, I think I nailed down my theory correctly on combining Hindley-Milner and forward flow typing. And all my test cases are passing, and including some fairly aggressive ones. No giant piles of code, but all the usual, like I cut and pasted test cases from other people's, hey, I've got a new typing theory thing, and here's the evil test cases. So I took a bunch of those too. It seems to be alive and well. I cleaned up the prototype, and I'm back into the main code base, and I'm busy starting to restructure things to support this. And that's my 2-bit status.
You've got some other weird ones that make Henry Miller go quadratic.
Well, make Hindley-Milner just say no. So that's the difference. There's a separate thing, which is I may have taken an asymptotic big O off of Hindley-Milner, and I'm not at all certain, but I have a sort of innovative memoization step, caching step that's not in the normal algorithm. That looks to me to take the top end off of the worst case scenarios, but I am not at all certain. Can we start Google Docs? Oh yeah, you want a Google Docs. You got a Google Doc thing you want in Google Docs here?
No, if there is a code samples, it's much more interactive there. It's much more readable.
Yeah, I need to figure out how to get a shareable Google Docs. Like last time Cameron did it, and
Cameron did it, yeah.
I need to figure out how to do it. Myself.
If you click the share button, there should be a share with anyone with the link.
Well, that assumes that I have a web page up that says, you know, make something.
You get to use the .new TLD by going to doc.new. Be all fancy.
I'm sorry, what?
I'm not on a good connection, so Aaron,
yeah,
why don't you start a document?
I Googled Google Docs. It threw up a bunch of things that have nothing to do with me at all. Documents that are up here are things listed from years ago, and things for my son moving into whatever, and Skyrim modding. So
yeah, the thing I was suggesting was that Google made a new top-level domain .new specifically so you could type doc.new and it would give you a new Google Doc, which seems excessive.
Ah, that worked. And then this link I can just share.
I never quite understood why in Google Docs any document you open is now shared with you. So you go through your list and you find this stuff, you know, a link you clicked on 8 years ago and it was some presentation, and now it's shared with you and you can't remove it because it's not yours.
Oh, but you can't remove the sharing, or they don't bill you the sharing, but it's in your shared with you.
Yeah, there's some limitation, like depending on how something is shared with you, you can't get it out of your list.
You did not share that correctly, Cliff. So you need to use the link that says everyone that has the link has shared read and write access.
Private, it says share with a giant lock on it. Name before sharing. Okay, CCC 7/16/2021. God, it's got me 1,000 things. Why don't you answer now? Stack nested answer at things. Copy this link. Try again. Done. Okay, try it again. Somebody bang on the link.
It's the same. It requires access.
Okay, try again. Add sharing. Okay, got it. I'm.
Yeah, I think you gotta have to add like people to it.
Yeah, this means I have to add emails to it.
Yeah, and
Oh,
for
here it is.
example, my
Change email
case,
to link. Hang on.
You should not have to type in anything. You just choose the thing that says anyone who has this
Yeah,
link
we're alive.
can edit.
We are alive.
We're alive. We got it. Somebody else type something then. Oh, I see people logging into it now. Okay, anonymous names, blah, blah, blah. Okay.
But I cannot write on the document.
You cannot write on it, but you can read where it says Cliff.
Yeah, it's currently view anyone with the link. It needs to be changed to edit anyone with the link.
I'm getting there.
Yeah,
I
cool.
still don't see.
Always the bravest of settings to let anyone on the internet.
Right.
What
Right.
could possibly go wrong?
Editor. Okay,
I
permission.
suppose when the call ends, we should switch it back to comment, huh?
Try again.
No, it's
Boom. Okay, fine. Well, that was a pain in the neck, but the
Yeah.
doc.new was certainly faster than whatever was going on
Look,
before.
we have to
So you
start
tell us
somewhere.
Google Docs very much.
Yeah. Soon
Oh.
we may have a REPL in Java and a interactive REPL.
Yeah.
Share it amongst us.
Right. They got to get the REPL alive for that. But hey, maybe that comes around. The REPL was alive for like 2 years a while ago, and then it's been dead for 6 months while I get that typing sorted.
There's always room to improvement to achieve.
Yep. All right, we have one new person, Alan, here. Alan, give me like 10 seconds of why you're here. What do you do with compilers?
Well, so I'm writing this programming language called Strasskit.
Throw the link in the chat.
Yeah, the keywords, I guess, is model checking. So there are all these static analyzers that build models of the program. And I decided that I'm going to go all in on model checking and use it for every part of the language. And yeah, I don't know. I've been reading lots of papers. I haven't really written anything yet.
I see. Yep. There's a lot of folks here that have the actually there's like several people here that are much further along, and some folks I think are in the zone of I'm exploring what the hell I can do here. Sounds all good.
So Alan, put a link into the chat.
Yeah.
If you have anything published.
Oh yeah, I put the link about poison values in the doc. So I just thought it was like I was watching the old sessions and there was this discussion of error values versus exceptions versus whatever, and so I thought LLVM's poison values were interesting because the idea is that you have something that returns poison if it doesn't work. Like, for example, division by 0 is a poison value. And then whenever you do another operation on a poison value, it returns poison as well. And so it kind of bubbles up or down.
Right. So I can tell you the good and the bad for the model. That's the IEEE double.NaN. And the goodness is, of course, is that you can carry on execution of things that are broken and then throw them away later. And the bad news is after you do 1 billion operations and you get a NaN back, it really sucks to try and backtrace and figure out where the NaN came from. So I did,
LLV
learning giant data set, company doing terabyte size machine learning. Somebody somewhere in the guts of one of the algorithms blew something, got a NaN, you ran on for an hour and your answer was NaN. Okay, somewhere in the billion pieces of data times billion times a second, you lost it. Fuck. Pain in the butt to go track those down.
Well, and the poison value in LLVM, it's not a particular value. It's just like it's a concept. It's a way to combine undefined behavior with some optimizations which speculate some instructions. So if you declare your division by 0 as undefined behavior straight away, now you're limited. You cannot speculate this division like anywhere unless you prove that there is no 0 as the what you divide by. But if you define your division by 0 if you divide by 0, you produce this like abstract poison value. And as long as you don't consume this value in a meaningful way, it's not undefined behavior. So this is the compiler construct to kind of postpone undefined behavior and to enable some of the speculations of possibly unsafe operations.
So it's not a user visible type per se. It's a compiler hack. Yeah, that sounds good.
So
Well, I mean,
what's
it
the
is
point to
user
delay it?
Because
Well-
you can assign a poison to a register, a virtual register.
Right. No,
It's a value in the language. Like, so
that's
from
what I'm
the
asking.
user-
Is it a user visible value? You just said yes, and Arthur was saying, well, it's being used in this non-user visible way, which
Yeah, it's
can both
not
be
a
true.
user visible value.
Okay. I get the benefit of using such things, and I guess I never called it that, but I have played those games in the past where you compute shit that
Yeah,
maybe not.
It's used in the SSA form. Yeah, it's used in the SSA form to avoid having one error show up a billion times in the log. You know, because once an SSA node is an error condition, everything that relies on it will likely have an error condition as a result. So by poisoning it, it prevents a billion errors from showing up.
This is LLVM's internal IR thing.
So I don't quite
Yeah, that's
follow
what the
the
link
point
was to.
of SSA like an error. But the motivation is to enable hoisting of some of the unsafe constructs to formally make it correct. Because if you define, let's say, division as undefined behavior, if you divide by 0, you cannot hoist it, because in a program which didn't execute this statement, if you hoist it early and make it execute, which wasn't happening in the original program, and there was division by 0, you introduce undefined behavior, which wasn't there.
Yeah.
So in order to make it possible to do this kind of transformations, it is defined that, well, it's not division by 0, which produces undefined behavior. It's consuming the result of this division, which produces undefined behavior. So
Yeah,
if you hoisted it out and never consumed the result, well, it's fine. Your program is still good form.
Yeah, you can imagine it producing an option tuple. Maybe it's got a value and it was okay, or is an error and shall not touch. And as long as you only eat the okay part, you're good. Yeah. So this is poison, but nothing to do with model checking.
Well, the reason model checking comes up is that I want to make poison like a first class value as part of the semantic domain.
Yeah, you go.
And so that's so like, why not have a poison value with a stack trace, right?
So I'm busy doing that very thing and have been doing it for quite a while. So I certainly track errors, including divided by 0, as sort of first-class citizens in the compiler IR. And as long as ultimately you never consume them in a meaningful way, you'll type and execute and all that shit. And if you consume them in a not meaningful way, you get a type error, and then it blows up. But you can have broken, untypable code in branches of code that are provably dead, as opposed to runtime dead. There's a difference there. Actually, one of them is you do a runtime test and you consume it, then you get a runtime error, which is actually sensible. Also, is a different thing. It's, you get runtime errors for divide by 0. That one's easy to avoid. It's the range checks on arrays that produce undefined errors that are hard to avoid or program your way around. So your program has to decide.
The difference is that poison value behaves a lot more like an error code than an exception. Because if you do an operation that returns a poison value and you never use it, then it doesn't do anything. It doesn't spread.
Yeah.
Yeah,
So
no,
what's what
Then it'll interrupt the flow of the program.
what is your stance about exception versus error? What should be exception and what should be an error? So it looks like it looks like to me that error is you are advocating for embedding error in the instruction flow, in the computation flow, like, if you will, because exception, if you define exception, it aborts your program. But the error has the option to return an error of some kind. So what's your stance about that?
Sorry, were you asking me a question? I couldn't really hear you. Let's turn up the volume.
Yeah.
Does your
But-
language have an
Question-
opinion on
Okay.
what's an
Can you
error?
hear me now?
Yeah, I
Mhm.
can hear you now.
So what's your sense on error versus exception? What should be exception and what should be an error?
Okay. What I've said is that everything is a poison value. And so
Okay.
the only question is whether the operation you're doing is a stateful operation or a non-stateful operation. Because if
So okay,
it's
go ahead.
Because if it's stateful, then the value, the poison value you get back doesn't let you access the state. So it behaves like an exception because the value, you have to somehow extract the state from the value, the poison value, to continue running the program. And so if it's not stateful, like it's a pure operation like addition or division or whatever, then it behaves like an error because it's just the value that's poisoned, and you're not affecting the state of the program.
I agree with this. Absolutely, yes.
I mean, yeah, I don't know. Like, I'm not really sure what to call it. I mean, there's only so many ways you can handle errors. So it's I feel like if there's a paper on it that explains this is how we handle errors in this language, I'm sure I'd cite it, but I didn't find one.
Google have an auto formatting with code?
Nah, Google doesn't interact with code much.
Yeah, sucks, but you could imagine. Size.
There's like a code block you can insert. It's like somewhere hidden under insert, but it's
somebody
last I
hacked it.
checked, it just makes the font monospace and gives it like a single color. That's it.
All right, well, somebody did it, and I haven't figured out how you done it, but that's fine. So this is a thing that I can type that Henry Milner can't, because the if statement on the middle causes the id function and the x03 function to be unified, which the unification basically makes a function that takes a 3 and returns a 3 is the only option. Then you pass it a string instead of a 3, and so he'll blow out and say type error. And in this particular case, the constant flow propagator doesn't get it either, because you need the id is arrow id to know that the execution of float fun on a string returns a string, which is passed in as the name field for the next iteration of the loop. Otherwise, the name's not empty, and you might have to take the other arm of the if statement. So that's a version of code that takes Henry Milner's id arrow id, lets you strengthen an input to the float fun, the result of float function be equal to its output equal to its input, and uses constant propagation to validate that all the different strings that meet for the name field are all non-empty strings or not nil strings, and therefore the if test only branches one way. Therefore, Henry Milner doesn't have to unify both arms of the if. So it takes facts from both sets and puts them on the other side to produce an answer that's better than either one independently. So
I have one question. We have spoke with Aaron for a little bit with this, but if we constantly pruning only the branch, the other branch doesn't even get type checked, doesn't get the risk this of the other branch that doesn't get type checked become stale because the program is never concerned with it. So it will keep accumulating changes. Only the branch which is type checked will keep only keep getting type checked, and the else branch can become stale like a comment.
Yeah, it has to pass the parser, but once it's dead, it doesn't get type checked. It gets type checked. The type check comes back with an error. The error is ignored.
Yeah.
But the particular error might vary over time. So this is an interesting point, and I don't know. So this goes to the maintainability of the code. You have code which is dead by design. You've written code which is dead. Okay, what do I do with it?
Yeah, and
Right, but it might just be code that you don't run often. So maybe I don't do my build for plan 9 very often, and then I come back to it 9 months later and it's broken because it hasn't been being type checked.
It's provably dead in the current build. But if you change some build flag that turns into changing some code, it says I'm doing a plan 9 build versus a Linux build, suddenly it's alive on plan 9 ARM, and then it gets type checked.
Yeah, but the problem is that the EOS branch can become much more stale than the version of the. Okay.
Right. So if I look at this in a standard C macro style, C++ macros would turn off the code in the off branch and it wouldn't even parse. And so it goes stale there too. And if you instead demand it's always compiled, then I'm making Linux hacks and suddenly my plan 9 build doesn't build, but I'm not a plan 9 hacker, I'm a Linux hacker and I have to go deal with plan 9. I don't know how to deal with plan 9. So there's a tension there that says, you know, I want the thing to compile or I don't, or there's a fail both ways. So at the moment I'm of the opinion that I'll let it parse. I'm okay with where I'm at. I'll let it parse. If it's dead, it's dead. And therefore, if it doesn't type check in dead code, it doesn't type check, and I don't care.
Yeah, one interesting point Aaron raises is that the EOS branch, which is getting constantly pruned, can be caught. Each state can be caught in the test. When you run the test for all of the builds, and that will include both branches.
Right. Well, if you don't run all the tests on your desktop, and that's what you get CI for, right? Somebody else runs 4 tests. But this is a compile time test, but somebody's going to run all the flags. I mean, I did this kind of shit before, both Hotspot and at H2O. We had builds for different setups and different environments. People all the time would hack code for whatever was their current desktop situation, that you'd go get a build fail, never mind a compile, I mean, an execution runtime fail. You get a build fail on the test farm because they fucked up somebody else's build.
Okay, that's cool. But if you look at the C code style macros, is become the whole snippets become commented away, or no. Here is a little different because it's the if else branches, and this creates more complication about the type checking, because like we spoke earlier, if you assign the if else branch to a value, that value has the potential to be different types depending on if it can get the condition right to know if it's going to be the else branch or the if branch that has the potential to be both different types. Right?
Let me get this straight. You're proposing that the if test has a Hindley-Milner type that varies according to the value of the predicate. So if the predicate's unknown, it's one of both values, you get the bottom type of the unification of both arms. If it's known in some contexts and not in others, you'll type one way and not in others. And this is polymorphic. As far as I know, that's what it'll do. Yeah.
So if you allow me to put in some kind of like ... I don't know yet, or there's some string here, but I don't know what that string is yet.
Well, who's virtual Arhus?
Could you make it be like, oh, actually build for all of the operating systems and make sure things check reasonably?
Oh, I see who virtual Arhus is. Hey, Jan. Just a second here.
I think this concept of dealing with like sort of platform specific code, it becomes especially apparent when you start dealing with a foreign function interface. Yeah, it's something I've been sort of thinking about, because in my language, the foreign function interface is what you typically find in a dynamic language where everything is done at runtime using runtime constructs. And so you basically get no type safety, runtime overhead of some plumbing that's needed, etc. Whereas in typically static languages, yes, some sort of DSL, if you will, to describe it, and then you have to annotate like, oh, this thing is only on Linux and this thing is only on Windows. I've run in cases there where dealing with, I think it was socket code, where on, this is something I'm moving away from, but I had this hack where in Rust, I was basically abusing file descriptor -1 as a way of indicating, hey, this file has been dropped. That way you could close a file or a socket before the garbage collector would kick in without having to use an option type. Because then if you use an option type, every single time you use it, you have to say, oh, does it exist? Whereas in case of file descriptors, the OS already sort of does that. But it broke because Rust ended up implementing an optimization where essentially, I believe file descriptors became optimized such that if you have an option type wrapping a file descriptor, it is the same as just a file descriptor, because they now use -1 as a tag of saying, hey, this is.
So you abuse the same -1 tag they were abusing.
Yes. And so I was now getting this weird test where basically Rust was thinking this thing is a none, but it was actually there. But this was tricky to debug because on both Windows and Mac OS, Windows and Unix, the code paths were different. And the types that they had to use different from different libraries. And of course, when you compile it, Rust won't tell you this won't work on Windows. So you basically compile it, run it in CI, wait 20 minutes, and oh, it breaks because I typed the thing wrong. Something like
But
that.
you have to have a cross compiler to cross compile to Windows. If you're going to get a type error, you're going to cross compile to Windows.
Yeah, this is basically
that tooling for Rust does sort of exist. As in, I think you can cross compile to OS X from Linux. Cross compiling to Windows, I think is also possible, but it gets tricky, especially because I use some C libraries like libffi, and they do not like cross compiling. I can tell you that. Like libffi in particular is very picky about it. So I'm kind of curious there as to sort of how you would approach that.
But let me go back up here. Aaron asked a question, and I was busy inhaling on, and I didn't get to it. What was the question again?
I don't remember. Sorry.
Yeah, that's fine.
So in like the context of FFI, what I've been thinking of, like, say you were to design a new FFI and deal with this sort of cross-platform approach. The sort of commonly taken approach is that you have sort of a base set of function types, etc., and then you sort of occasionally add exceptions to it. But that basically makes it impossible to statically determine, hey, is this foreign call going to succeed? What I think of this other approach, where basically per platform you have to list all the things that you want to use. And then at the call side, you also have to indicate, oh, if the platform is X, call it this way, else, and then you can sort of type check it statically. But I fear that ends up being very verbose. Because basically, if you have, say, malloc, which is basically the same on every platform, every time you use it, you end up with something like, oh, if Unix, malloc, if Windows, malloc, if macOS, malloc, etc.
No.
So
what I'm advocating is type safety via the standard normal language syntax. But you could certainly have a malloc that was a function that was defined by saying, if Windows call this malloc win malloc, and else call DL malloc, else call whatever, and then, but everywhere you use malloc, you just use malloc.
When I basically think of this these two ways.
Nice links in the chat.
Yeah, okay. At the one side is what, like you said, the ability to conditionally include a branch, to conditionally include the code which is platform specific, which is basically charting the path for the end of the program, basically on which branches are switch on, which branches are switch off. The other way I think about it is to build some kind of interface, because the thing you have to call it has to be there. Let's say I work it on an issue lately that it has to call with different settings mmap. There was one specific issue that the mmap has to be pre-allocated, that that pre-allocation flag is only available on Linux, let's say. on Mac OS in BSD, you have different options to switch on or off the map pre-allocation, and on Windows it's completely different API. It's alloc and commit settings, something like that. And basically, you have to build an API around these three different types. You can do it with the if-else branches. If it's Linux, do this. If it's Windows, do this. Or basically, you can build an API so you can call mmap and that mmap to dispatch the platform-specific code on each invocation.
Yeah.
So these are two ways to approach this.
But I would think that would all boil away nicely, that you know which platform you're building for, so that's a constant. So your if has two dead branches and one living one, so that can all be inlined. And
so
like,
that's
you have to hide all that in a function, but it seems like it would boil away.
Yeah, this is the approach I did go because I did only the Linux platform specific. The different guy do it for the Windows, and it's basically a one API, but it's an if-else. It's a macros in C, but the API is the same. That will allow you to treat the API homogeneously on the all platforms.
That's the approach I'm angling for. Is that in the end it'll be one API that you'll have an if-def, except it's an if instead of if-def.
Yeah, that would be much more stable way, at least in my opinion, because you standardize what to call, not how to call it.
Yeah.
And in the Rust example, that with -1 if the Yorick, I believe this is a classic trade-off because you treat a value as a type. In order to escape allocation of the option each time you ask it, you treat a specific value to a non-type. And this can on if it's -1, it's -2 on the Windows, and you break your API because that guarantee is gone. This can be either done with dependent types, which complicate the pictures because the dependent type can check if -2 corresponds to the non-type, but it becomes much more complicated. At least in my opinion.
There's a general theory here that says in any domain, people often want to have another thing, which means not missing, NaN, nothing, and they want to extract one member of the domain that they consider extra and take it out of the domain and then treat it special. So nil for pointers, -1 for your file descriptors. After Rust steals -1, you can steal -2, right? But there's a large domain of plus and minus, 64, 32-bit ints at least, of which file handlers take 65,000 of them. So there's a lot of extra bits. So you'd like to steal some members of the domain, but you like to steal some members of the domain in a programmatically type-safe way where we all agree ahead of time we're going to steal a member. I don't really care which member you steal either. So, can't you all agree that between everyone who wants to steal from the same domain, we all coordinate on which ones we're stealing?
This is the key keyword, the coordination. The value doesn't have to be there, and all of the program can coordinate which value has to be what. That's.
There was some language, I want to say Zig or Zigzag or something, that was doing things with error code. Zig.
Yeah,
Zig.org. I'll throw that in the chat here. This guy was doing fun things with merging error codes across multiple semi-related domains, sharing where he could and stealing spare bits otherwise to get you a single uniform, well-typed int value. So 32-bit int value, we all agree was an int, but the special numbered were carefully selected to not overlap on each other, so you could merge them into a single value. That was one of his hacks. The other one is he did cross compilation as his normal mode all the time, which gives you all kinds of, your Mac, Windows, ARM, microchip, whatever things all have been beaten sensibly with their like internal make system does.
Yeah, the cross compilation pipeline is on point. It's a very fine piece of software, and from what I heard, yeah.
Yeah, I don't necessarily agree with some of their other language choices, but some of the stuff looks really cool.
I think the day there's a language everybody agrees with, I think it's probably the same. Well, it's probably the same day there's no stars anymore. So
yeah, fine. Yeah, fine.
A choice of a language is a much more involved way than just a keyword. It has to, you have to appreciate the concept, you have to appreciate the approach you write, you structure your code, your data structures.
Yeah.
And basically that guarantees almost that there will be no a ring to rule them all.
Yeah, yeah.
But what about Lisp?
Oh, stop that. No, Emacs, not VI.
If Lisp was a static language, well, okay.
Oh, you know, Lisp deserved some good praise for what it did at the time it did it. That's what I was saying last week about COBOL. You know, what does COBOL have that no one else has? Well, it was alive and well in the 60s. That's hard to say for, you know, nearly everything else.
Yeah, let's talk about Lisp for one concept, code like data.
Yeah,
So,
yeah.
Yeah.
Well, a bunch of folks have been playing around with this thing now, and I haven't figured out. I mean, my take on that one has been, first, I'll just do the ifs and have errors, but the second piece is I'll just have a vowel in the language and some convenient way to pretty print your program into a string, hack it, and then eval it back. And it's strongly
What
typed.
if I want to keep it as more of a SSA form? And
So
give me this thing as an SSA, and then I'll manipulate the shape of the thing, and then I want you to generate code for me.
Right, and here I've gone back and forth. So as soon as you say I'm handing you compiler IR, the user has to have a huge amount of learning curve to understand that IR. Then they directly hack it, but the IR still has to be entirely validated on re-inhaling it back, because you can have all kinds of shapes that the compiler's never seen before, you know, even beyond the static, it just types. Whereas if I say, hand me a fucking string back, I'll run you through the normal parser. That's the validation step. Do the normal type checking. That's part of the validation step. You get a thunk or an error code. So it's a little more, it's easier to read and understand. It's a little more overhead for inhaling. I can't just take the IR and then run it through the code gen and go. So instead, it's got to run through the type checker first. But on the flip side, boy, it's going to be easy to write the code. So I did this with H2O doing the serialization stuff. I went back and forth for a little while, and then figured out I used Java Assist, and I just would write Java code as strings and hand it to Java Assist, who would class rename it. And that would give me my custom serializer for every data type in the system. I would get a.
So when you were sending logic over the network, you were doing that as strings of Java code?
The logic over the network was handed jar files. So the custom serializer was there so that you could change your data structure freely while you're doing development, and you didn't have to care about the serializer. You just ran it. And the first time you touched the network with the data set, I want to move this over, I first hand shook how I was going to serialize it. If that came back an empty, then we asked Java Assist one time on every node in the cluster, here's how we serialize you. And you got a custom name for it. And then the next time you sent data over the network, it was a 2-byte header saying this is the entire structure of the whole thing. That's your protobuf, was 2 bytes, followed by the data, however it got compressed, and we did all kinds of fun games with
things like that. Tend to work well for networks and poorly for disk.
Yeah, it would work fine on disk too, generally speaking. Mostly we saw the usual compression for standard sort of structs. We did a lot of games with arrays. So a lot of structs had nil fields. We did a bunch of shortcuts on nil fields. Then we had a lot of arrays that were variable size and only half filled in the leading or in the trailing, or they were declared long but only had values in the byte range and shit like that. So we chopped leading and trailing identicals chunks that were usually 0, and then we chopped storage volume if it was typically limited to X bits. That's how many bits you use per element, kind of stuff. And that was the limit mostly. The end result, though, is we'd usually get a 2-to-1 to 10-to-1 reduction over your in-memory formats. Those are pretty dense. That was nothing to do with the in-memory format we used for the data when we were doing execution. This is just the wireline format.
I mean, there's advantages to having the in-memory format and the wireline format be identical.
The in-memory format was optimized for throughput and math speed, and the wireline format was traded off CPU for fewer bytes on the wire. But mostly you didn't have to do any annotations whatsoever to get something over the wire. So you could just hack your Java code freely, hit the go button, and it ran, and it still did good wire format size things and the like. But that was because we wrote the serializer in Java, and it was easy to manually generate the Java code, manually read it with your eyeball to validate it was correct. I even spent some time pretty printing it as part of because of course, the white space consumption takes no time at all in the compiler. So it was easy for Java Assist to destruct it into bytecodes, but then I could read it when I had a bug and see, oh, the serializer screwed up because this was a transient final field and it did something, I don't know what the hell, something happened funny, and you lived through it and sorted it out. So I'm in the mode of, if you want to write code that's meta compiled, maybe you should write it in your host language. And I'm happy to be talked out of this. I've seen that compiler IR thing come around.
I just worry about things that smell like SQL injection. Oh, someone built this thing and they injected a string using string format into the code, and they got arbitrary code execution.
So the little Johnny drop tables, yeah.
Yes, little Bobby drop tables. But yeah, the XKCD one, yes, it's hysterical. No, the theory there is that eval should do the right thing. So eval type checks you, and eval type compiles the code in the context that you give it. So if you give eval the rights to go blow your brains out, you do. But if you tell eval, hey, I'm inside of a private box and I can only see the following injection points, like I'm only going to pass you the following args that are only known to whatever as the function, you get a thunk back. You pass it, whatever you're going to pass it, and run it. It doesn't get access to everything on the planet unless you've opened up yourself. So if you call an eval, so this has to be something where by default, I'll make the defaults be completely closed in, have no access to anything. And all you can do is make random numbers and compute Mandelbrot's, right? And then you have to open them up one by one by one. There you go. This is probably it. This is an old one, right?
Right. When I call eval, I should also pass in a struct that says this is the environment for the eval, and you can access any of the symbols that are in it.
Right. You get some sort of eval environment. And I haven't sorted it out what's the right level of easy thing, but the obvious one is in the function that's calling eval, you get access to the local variables in that function only as by default, or something like that. So you can do something easily as a handoff, right, what you call eval, but you don't get any global access whatsoever. But we can argue left and right, up and down, what's the right level of access to have here. I'm all happy to, what's the default? But the semantics are that the uses is you wrote a string and you executed it. And if somebody wrote a string that whatever tries to drop tables, it shouldn't have any access to your JDBC driver, so it didn't matter. Those string injections are because they took a string and they plunked it inside of an SQL query and made a bigger string. Then they handed that off to the database. And I'm claiming that that's not what eval is going to do.
Okay.
Unrelated context.
Cool.
Yeah, you lose all your context.
And the issue with Java is that for the most part, the runtime is a global context.
Yes. As a minimum in Java, you can ask for like all the class names in the planet. You can even iterate.
Which is why if you accidentally use a library that drags in anything from Apache, you were automatically vulnerable to that 0 day last year with the or 2 years ago or whatever.
Yeah, Apache struts.
With the remote.
Apache struts.
Yeah.
Yeah. What was the?
No, it was some Apache Commons. It wasn't. There was one of them that dragged in something from Apache Commons, and that had about, it's like 10 levels away.
That, but yeah, I stay away from Apache Commons, and I don't drag things in by by default. But I know people who do.
Well, you can't stop it. That's the problem, because it's closure.
As soon as you have an external library, it's stopped because the name's undefined. Somebody somewhere has to come along and say, okay, I'm going to go over the wire to Maven and download Apache Commons.
Right.
I say no at that point.
That's what I was going to say. If you use Maven or Gradle or whatever, it'll automatically download the internet for you.
No, right. No, if you're playing those games, then you're going to get it that way. Sure enough. But that just goes to the, what's your trusted computing base? And the answer is, I'm going to claim my trusted computing base includes Apache Commons. Well, okay. See, I claim I'm going to have trusted computing base as like a keyword thing. So if somebody else comes along and says, I'm going to, I want to compile this code over here, but I insist that this guy's trusted computing base includes only, whatever set of things I'm allowing. And it's a type error if his trusted computing base includes, for instance, Apache Commons. Okay, no, won't compile. There's an error there. And that's just, the truth in advertising on your code. Some top level typing system on your code says, I wrote it, or I wrote it plus also I wrote from whatever came with the core library, or I wrote it plus whatever, everything that came off of Maven or Apache Commons or some select set of things or whatever. But there's some top level thing that says, here's the range of my computing. And if you're going to call me, you get everything I do, everything I've touched. The poison bit spreads ever wider if you let it.
So on the side, there are two ways to send code: to send the source code, to send the abstract syntax tree, or to send the compiled program and ready to go. Which one of the three is the most preferable? I'm thinking about. Okay, let's say if you if you're sending a binary functions compiled to some unknown language, but they are functions and binary, would you prefer to the source code to interpret it on the spot, or the AST, that's halfly baked binary program, or the binary program, which is callable, the assembly code, which is directly callable? Which one?
Depends on what you want. For me, it's going to be a case of, if I can't verify you, then you're a foreign function interface call.
So how do you verify something?
Well, I can do some modest amount of, typed assembly verification, or I need source code.
Okay.
So if you hand me something that's written in a typed assembly language, I'll validate that it follows whatever rules comes out of that. Otherwise, I need source code. Otherwise, I declare you an FFI. You called unsafe, and God only knows what you did.
I would argue the fact that we're passing around JavaScript as source code is the reason the web worked.
Yeah, right. I understand that. Every machine independently validated the code, love it or hate it.
Yeah, but the problem is,
but you validated it sort of high level. You've never.
You have to have the interpreter on every machine on the planet.
And you have to JIT it, and you have to compile it, and there's all this overhead, and yet the security made it possible. I think at 100%, Aaron, that was the right answer.
So on the next step of this conversation is to hot code reloading. How to approach it? I know there are different approaches. I doesn't know which is the best. Hot code reloading.
Hot code recompiling.
You track what the new code that you just discovered is, and if it invalidates stuff you compiled before, you recompile it.
There's an obvious. I'm sorry. I mean, it's not obvious. There's a thing in here that's been around forever and a day, and that's if you are calling some code and it's hot and you want to upgrade the version number, now you're calling new code, there comes a point where you have to do an atomic swap of old for new. So typically you have to decide the old code reaches some fixed point where you can declare it's done in some way, and then there's a substitution for the new code thereafter. This is very, very similar to safe points and hotspot and garbage collections and the like. There comes a point where you could stop and say, I understand the abstract situation. I can now do some sort of semantics preserving swap and start again. And for that to actually work, the hot code has to exit into some outer loop, server loop, who says, I would call the hot code again, but instead I'm going to call the new version, and you get the version upgrade at a safe point, which in your code had been structured that way in the first place.
Yeah, it's a hot code, or just code reloading in general, is a incredibly, surprisingly difficult topic. I think Erlang is probably one of the few that gets it right, and as far as I understand, at least. And I think a big part of it is because it's immutable.
Who are you talking about here?
Erlang.
Oh, Erlang.
So
Oh,
they can do it
yeah.
because it is functional, it is immutable, and so reloading a module is more like adding a new one, and yeah, at some point deciding, hey, now call this new version.
Yeah.
You don't get
Yeah,
these
you have to.
nasty.
It fits nicely with their whole let it crash attitude of, if I've got this whole tree of sub-processes that answer some type of query and I make a change toward the root, I can just like remake everything under it and be like, all new queries go there, the old queries can finish, and once this is done, it all just GCs away. Like,
Yeah.
No,
Right.
exactly. And so
Yeah.
but in languages that are immutable, let's say Ruby, Ruby is not just mutable, it's also a very flexible dynamic language. Code reloading is basically a nightmare. Like, there have been many projects doing this over the years for both Rails and non-Rails projects. You will always end up with some issue where you've reloaded code, but some constant whatever thing didn't get reloaded, and now you have new code operating on old state. It works okay enough for development environments, but it's a bit of a pain. And so I would say that in the context of a language, you either have to build your language around it, or don't do it at all and just rely on people basically restarting the whole thing. Or in like more modern terms, you have a new process starting up somewhere else, and then you basically do it at the
Right.
load balancer level.
The natural server boundary between old and new is the actual process on a Docker container, and you've already set yourself up to be service-oriented architecture with easy restartable points.
Yeah, and I think
Slow
they're
down and put a new one in.
if you
We
put
have
it
to.
at this. Sorry, go ahead.
No. Finish your thoughts. I have
I'm
something to
watching the
say.
chat go by. That's all.
Yeah.
No, I was going to say that if you do it at the server boundary, or let's say the process boundary, that is much easier because typically the external services you would use are already built in mind with how would you type it? Put it this way: if I have a database, like a SQL database, I can have different versions of my code. The database itself doesn't give a damn; like it will handle it. And so if I restart, add new processes, don't need to do anything extra. But if you do sort of in code or in application code reloading, now you have to figure out how I'm going to load the new code in, how am I going to change state, how's this going to affect my JITs if I have any, that sort of thing. And I would argue that if you don't build that in your language from the start, which I think will basically limit you to functional immutable languages, I would say don't.
So we have to, of course, we have to go to consider at what point we want to swap the code, at point of a function, at point of a module, what module ever it is. But let's say if you are throwing binary functions compiled to assembly and you just update the pointer to point to the new function, that is almost cheapless, it's costless. Of course, there is security implications around that. The other way is to the source code to interpret it again to have a compiler essentially in your on this machine to compile it again and to kind of hot swap the
but break out the difference between validation, verification of new code and the execution engine used to make it go fast.
Okay.
Because the execution engine can be as simple as an interpreter that written in 1,000 lines of code, and it could be as complicated as a giant C2 optimized compiler. And you might have profiling and multi-tiered compilation steps and all kinds of shit going on. And just those are separate notions. If I want to load new code and replace some old code at some targeted point, I need to verify the new code is semantically correct in that location. And it may not do the same thing, so semantic correctness is limited by what the language does, but it gets that far. And now there's an execution engine. Figure that one out. If you want to have static compilation ahead of time because you're an embedded thingy, then you can't really do this.
Yeah, if you consider the J-rebel approach, it can basically hot swap functions while it still runs.
Yeah.
But if you consider that the J-buddy, there was some library that also does this, it can replace some methods that are already there, and with it have to do different things to basically allow infinite redefinition or something like that in order to introduce new code while your program is changing.
Mm-hmm.
which is the harder approach to I'm
Well,
considering this approach.
You set your semantic swap points ever more finer grained. So you have a
Yes.
safe point in the code, you have a bytecode, whatever, you got some new code you want to swap in, you have to do some sort of semantic versioning, whatever, repair step, and then you declare that that's your semantic correct new version, do the mapping, and then go again. And I guess it's well understood. It has all its limits. For me, the hot swap thing, like 99% of the time, doesn't work. And I mostly don't care for it, but mostly it doesn't work either. So I don't know, people all got excited about hot swap, and it's offered in the debugger all the time. And every time I get a message saying, and hot swap failed here. And I'm like, well, quit telling me that and just fucking rerun. Why? You know, I don't know. Quit trying. You're not ever making it work. So why are you trying?
Yeah, but I think that's the thing. Like, if it's not built in, I think a lot of languages like Python, Ruby, etc. Basically, their form of code reloading is basically just eval the file again. Just hope it works.
Yeah.
And I think if you don't have global mutable state, it probably will work most of the time.
Right.
But in Ruby, for example, you get these fun things where constants are meant to be constant, but in typical Ruby fashion, you can just redefine and reassign them, and it will produce a warning. And so if you work on a big Rails project, for example, and you reload some database model with constants, fat chance your terminal is going to be full of warnings. Oh, this constant is already redefined, but we're doing it anyway. So it kind of works by coincidence, I suppose.
Yeah. Okay.
There is a big Rails project to
do this. If I look at large commercial software systems, everyone has decided that like Google isn't allowed to turn off for an hour for a maintenance update. Twitter isn't allowed to turn off for an hour for a maintenance update. So they have to have some kind of hot code reloading. And they've decided the way to do this is microservices and run 10,000 different services, each of which are going up and down and sometimes running different versions. And like, if the languages enabled us to just say, hey, this piece of logic is what I need to swap, I think we would have a lot less problems with entire complex systems that are being broken down into way more services than they should, because every time I want to have a unit of hot swappability, that's build another service and all the monitoring costs that come with that and all of that. Like, it's a really expensive way to get the feature that a language might be able to give us.
I don't accept that argument on the face of it, though, because it's much less about microservices and much more about partitioning the incoming load. So, for example, most of the magic by Amazon, Google, etc., is a combination of what's called global load balancing and local load balancing. So the global load balancing is actually a DNS trick, and the local load balancing is a TCP trick. But in both cases, it's a level of redundancy that allows them to incrementally migrate slices of the load from an old version to a new version. And so it's not so much that it's a microservice, but that there are fault lines that allow the continents to move without the end user being aware of them moving, and more importantly, a lot of things are actually broken as they're moving, but they're able to hide the broken behavior from the end user. So it's far, far uglier than you could have possibly imagined.
So,
and it's not about microservices, it's about hiding error.
What I heard Aaron say was that the microservices was the boundary of hot swappability. And the key item here is there is a boundary of where we can hot swap, and the user, the programmer, declares where that boundary is. In the case of what everyone's
And
talking
I'm-
about, they picked microservices, but that wasn't
And
why.
I'm saying in reality, the boundary is a fake item potency that occurs
Yeah.
at the intersection between the end user and the outer layer of the network service itself. So far before you get to any network services, what happens is your incoming request is treated as item potent, even if nothing behind it is actually item potent. And what that allows them to do is if there's a failure behind the scenes, they simply fail over at the global or local load balancing level to hide the fact that there were errors and retry it on potentially a different version if they're in the middle of upgrading.
Yeah, well, assume that they're always in the middle of upgrading. That's their normal mode. Yeah, but now the can you get language support? Like the support that they have is that they've picked not they, but some set of people pick microservices as their unit of hot swappability, of load balance, of maintenance and monitoring for whatever, and that's where they get to do the upgrades. And the downside of that, of course, is horrific costs.
Yeah, I think Aaron makes a good point, though, is that there's opportunity to move that down the language level so that parts of your application can swap, without necessarily implying, like multiple servers being involved in the change.
Yeah, right. Right. Well, this goes to Erlang's model, right? There's somebody swapped out at a well-known, well-defined point. Somebody swapped out and said, "Okay, here's the new one." The old one finishes out, and then the new guys go to the new one, and then if that succeeds,
Or Erlang's
That's what I
modern
was suggesting.
competitor. Erlang's modern competitor, Kubernetes, which lets your whole Docker container just let it crash and then start a new one.
yeah,
That's kind of the point I was making, is it's far less micro. When you're letting entire.
yes.
when-
Well, it's called microservices, but yeah, I don't know. They do an H2O, the overheads that you get out of like Dockers and Kubernetes just like far exceed what you can, what was sensible. So there is a much more efficient way to go, and can't we have the best of both worlds here?
The person who finds this the most efficient switch in the code evolution and the code swapping and figure out the stability of this will get the prize for sure, because I believe it's a hard problem.
Well, that's why I want new languages to put a lot of time and energy into, can I load new code at runtime? Because if I can say, deploy this VM to 1,000 nodes, and as this server starts getting overloaded, just call the server next to it and be like, here's all the code, start running me also. I need more of me.
Yeah, from here we can really go off the rails, because you can have let's say 1,000 servers. One of the server has to have become overloaded. It lift the flags and start migrate all its functions to a nearby nodes, and basically don't die. And basically we'll build Skynet from there.
It's a long step from I'm overloaded to Skynet. No.
Okay.
Skynet definitely needs runtime code loading.
I think, Aaron, you're kind of arguing against yourself here. So I guess I have 2 points. One is, you talked about sort of doing it at a lower level, but then you argued, well, we need, multiple other servers to help out. And so now your example is at a different level. My other point, though, is I think there's a whole lot more money involved in the case where there are multiple servers involved. And so that's where the attention is going to go, and not, the problem where, okay, I got an extra thread I need for this. And, like the small scale problems are going to get small scale money. Right.
Yeah.
I think there with at least one of the reasons I personally just don't care too much about code reloading is because this whole sort of infrastructure you need with like load balancers and multiple processes and servers and it's not really there for code reloading purposes. It's there for redundancy. And I would argue that even with Erlang or any hypothetical language that has excellent support for code reloading, you still want that. And I also think that the amount of service, it is influenced by the language, but I think it's more so influenced by basically the people writing the actual code. So as an example, Ruby on Rails, for example, is typically considered slow and bloated, etc. And to a certain extent, I would definitely agree with that. But it's not slow necessarily because of Ruby. Like if you take Ruby itself and you basically take the most basic hello world over HTTP, it's actually really damn fast. And it's all that stuff that comes on top, it kind of slows it down. That's how you sort of end up with, oh, my my Facebook for Docs service needs 5,000 servers or something. I don't think code reloading would let you reduce that by any significant amount. I do think code reloading is interesting during development for REPLs, rapid iteration, that sort of thing. But I think that's where you typically have a bit more flexibility in terms of how you do it, because it doesn't have to be perfect. Because worst case, you restart your development environment. You're not going to lose, a billion customers in the process. But if you do this in a production environment, yeah, you want to be really careful, basically.
Yeah. All right.
Next
Does anyone
topic.
mind if I ask a total bike shedding question?
Go for it.
Go ahead.
So Clojure has all commas as white space.
Oh,
So if you put a comma or a space or 10 spaces or new lines, like it's all just the same. And Python will let you put underscores in numbers anywhere, and it just sort of ignores the underscores and goes, you figure out how to group things in reasonable ways. You want to group by fours, group by fours. Do you think it makes sense to have a language-wide both of these constructs to say, oh, this visible character is white space and will always be treated as white space, and this visible character is no space and will always be treated as if it is not there, language-wide, so that people can format things nicely, however helps them understand it?
Wow. Yeah, like I'm running out of, I don't have a whole lot of spare characters to throw around.
Have you used comma yet?
I like the underscores and numbers for big numbers.
Right. So Python only did it in numbers. They didn't do like underscores and meaningless character everywhere in the language.
Right.
But I do think it would be curious to do this is my visible nothing and this is my visible space.
Yeah, the only place I'm using commas now is argument separators in like function call arguments and tuples.
But you can use spaces there also, right?
No, because right now, two things that are only separated by space make a functional style call, application point call, as is common in functional languages.
A space B is like lambda calculus application.
Yeah. And only for certain, it's harder to make mistakes and have it happen when you didn't mean to, because I force things to.
I thought your rule was no subtle calls.
No, that's the one. I went back and forth on this one, and I said there are two. So you're right. I said no subtle calls, and I should change the comments, the code, because the other one I'm doing is I am allowing just a one argument to one argument call that is done as a. It's not.
So adjacency is function call with one argument.
Adjacency is a function call. Yeah. That was actually done strictly so I could do nicer looking for loops in
yes,
user
it does
mode.
make writing if and for look prettier if I can just
if you can
trail a
write
block
your own
of code at the end.
Yeah, you can write your own ifs and for loops and do loops and have them behave how you, you can do what you want. You write your parallel distributed for loop and it look like a for loop because for loops just look like normal user applications. So I went back and forth on that one and settled on that version of things. Secretly under the hood, I didn't tell anybody, is that all function calls in AA are actually done as a functional style application, one argument, but you usually wrap a tuple afterwards, like a C style, and the tuple is passed as the tuple, except that I syntactic sugar break it down. So the actual parser just all knows.
A function call with parentheses is just passing a tuple into a function that's just one argument.
Yeah. And then he does syntactic sugar and breaks it down. So the parser just all treats it as a function call of one argument, happens to be a tuple.
So if I want to use named arguments, I just use a struct in the same way.
Yeah, if I want to get done to named arguments, I have to go sort that one out. But I don't have the syntactic sugar for that, but I could. Yeah, sure. Right now, if you passed a one arg named struct, it would just get passed as the one arg as the not broken out struct. And there's short syntax to explode the fields out, but I could explode out more. Certainly, a method call does that. The method call has the implicit this pointer, which is your struct, which then it gets exploded in your namespace. But that's semantically identical, syntactically, you make it look like a.
Do you have a this, or they have to choose the name of self like Python stuff?
No, there's an implicit this. I'm not going to necessarily name it this, but there's an implicit name. I threw the syntax out for that earlier. So I even have slides. You guys didn't see slides because this was rebase, but I can pull up shareables here if I can go find it.
Well, judging by background, some of us were at rebase.
Yeah. Some of you were at rebase. Okay. Share screen.
I would say that for numbers, having some sort of separator is really nice. Like I like the underscore approach. If you do dots or commas, it might end up conflicting with actual arguments. Like if you have, say, 10,2, is that 1,002 or 102 as arguments?
Yeah, 10,2, I kind of want to be a tuple of two numbers.
Right.
Yeah.
And you would also end up with the argument, which one do you use for decimals? Because Europe and the US and a few other countries disagree heavily on that.
Yeah.
And at least for me as a European, where we use dots for thousands and commas for decimals, the other way around is profoundly confusing, especially if it's not apparent. So you use some software like
the reverse. We use the thousands.
Like, let's say you use Excel, and
and
it says like enter a number, and your number's 42.5. You're like, okay, wait, am I supposed to use a dot or a comma? You know what? I'll try one of them, and then it will just convert it to NaN. You're like, okay, guess it's the other one.
I'll say, all right, I'll sort on that one too. I didn't think about that one.
And so I would argue the best way is to use spaces for just separating them, and actually dots for decimals, simply because that's mostly what we use in like most programming languages. But then with spaces, you still get these ambiguity issues, where if you have, say, let's say you have a language where arguments are separated using spaces, not commas. You have, say, foo parenthesis 10 space 5. Is that the number 105 or two arguments, 10 and 5? And I think that's ultimately why I like the underscore approach, because there's no ambiguity. It's just a little parser complexity, but it's fairly doable.
So I threw up the slide on method calls just to show X and Y getting exploded in the namespace inside the function. And the leading dot was the indication that this is a method call. But I don't have a name. I haven't figured out this versus self versus just never allowed to say it. It's always apparent from context. So that's it. The one wrinkle here is that dist is just a field every time. So .2.dist at the bottom there, that's a field lookup, which pulls the value out of the field like you'd expect, which is a function call, which gets called immediately. And the only wrinkle.
So this is the presentation you did with Chris Lander.
With Chris Lander, yeah, rebase. Yeah.
Sorry, I missed the first half. I just have work. What did you got from this conversation? Like,
the conversation with Chris?
Yeah.
Let me. He was. What did we talk about? That there were some things that I need to go look at more. And I think we agreed that we didn't quite get each other's deep, meaningful whatevers. So there's a thing to do with who does lifetime management in the ref counting world, and how it pans out. And it's values to value semantics for function calls and the cost model. That was the open question that banged around a bunch. So if you do value semantics, so Swift has both value and reference semantics. Classes do reference semantics just like Java. So structs are value semantics. For small things, the compiler is all happy to just explode them into registers, as you would expect. For larger things, they do a cow operation under the hood. The issue then becomes if you mutate a value object and it's large enough, then the first mutation does the copy. And so the cost model for mutating a field becomes either it's a store or it's the first copy on this path. And so I made a complete clone and I did a heap allocation. And then I ran off and did your store. So that's a different cost model. I haven't wrapped my head around how to program it to people or have people understand what the cost model is. And one of my goals at AA is to have a well-defined, well-understood cost model. And I think I've got it pretty well nailed down in most cases. Your this costs are cheaper and the syntactic sugar can all be pushed away and you can ask for it to not happen because you don't want the cost and yada, yada. Here under the value semantic model, some things look really good. Like you just did, it's a value thing because I want to do a complex pointer, which immediately is so small. I'd rather be not an object, but a value and yada, yada. There's a bunch of places where you want value objects. But, you know, what's the cost? Well, it means mutation has a variable cost, depends on your flow path through the code. I didn't write, and so every time I made a copy, I did a pointer plus plus minus minus, and the optimizer cleaned it up, and I'm hoping that cost remains modest and there's no cross-thread sharing because you just made a clone of it and whatever. There's ref counting, I'm hoping can be made cheap enough. I don't know, it can be made cheap enough. But it's not zero, and it can be large if I accidentally mutated a large value that I should have been doing a reference semantics on because it was a large value and I didn't want to mutate it by mistake. So the classic fail mode is some languages like R where I made a big array I'm doing data science with. Somebody somewhere made a mutation to it because, for instance, they're imputing the missing values with the mean or something stupid. And suddenly they made a copy of a big array. Well, that's a fucking expensive operation. You can't do that very often. And maybe they meant to do update in place. And the language is not making it clear that you're making a copy as opposed to an update in place. So then it becomes, you know, how can I tell that it's a reference or not? And what's the cost? And maybe that's okay. You know, maybe the answer is, if I'm going to have a giant array, I'm going to demand it by default be a value, be a reference semantic, and you don't get value semantics on arrays unless you hard ask for them. But you get value semantics for structs, and as long as the struct has, you know, 5 fields or less, no one cares. And if it's got
or go the other way and say, because this is a large array, I want to tag it as like no for serious reference.
Well, that's what I'm saying. Like arrays have like the compiler, the language typing system typically can't tell you the size of an array. If you happen to know the array is typically going to be 5 items or less, you can ask for it to be value semantics. And if it happens to be 1 million elements and you declared value semantics, you're probably going to suck. On the other hand, you know, if you say it's always reference semantics on arrays, it's actually probably pretty normal for people using arrays. They're usually read-only because I'm just looking at piles and piles of data, or I have some sort of it's going to be big notion in my head. That's why it's an array. And therefore, I want it to have shared reference semantics, and therefore mutations have to be careful. Whereas structures often can be thought of as value things that I'm just going to say, I have a person object, I have a home address object, I have a phone number, I have a connection object. And if I make changes to it, you know, semantically, everyone else can not care, and I'm just going to pass around the modified version. And ultimately, I'll eventually put it back in some reference shared place where I do a mutable update when I write it back to the database or wherever I store these things. But while I'm passing them around, it's a value, it has good, easy to understand semantics right up until the time where I start making mutations and I get clones and clones and clones of it, which have way more cost than the reference semantics I thought I was dealing with. So, you know, I'm still sorting out cost model for that guy. And there might be, you know, might be valuable, might be a way to go. So that was the major takeaway for me of what did and didn't happen. Everything else we kind of agreed that was less important, or we could let it go left or right. I'm not, obviously Swift's around a decade and my language has not got any user.
What was his sentiments about the type system and the things you do and try to push the boundaries of the current type system improvement?
I think he agreed that type inferences is good in general. We didn't go down that path very far, so I couldn't tell if that's because he wasn't interested, or he settled on his type inference he likes, and it requires some amount of annotations because it's Swift and you just require some annotations, or if he'd rather have more or less. Java has gradually allowed you to have less and less type annotations. And that's been a hard push from the community that says, oh my God, verbosity is killing us here. Swift is, near as I can tell, roughly in the same boat that Java is in terms of the amount of overhead of type annotations you have to have. Wouldn't it be nicer to have fewer required? I think he didn't disagree. I don't
think the bloat in Java comes from type annotations, though.
I'm sorry, what?
Type annotations are the least of the bloat in Java.
For me, they're a fair amount.
Especially if you go with generics.
Right. As soon as you say right.
Generics are poorly designed, though. It's not so much the type annotation as it is the generic system itself.
But that's the type annotation. That's the type system that Java has. It was backwards compatible. They made some choices to keep it that way. Suddenly, I have to write hash table of bracket, string, comma, capital I integer, blah, blah, blah. And I have to write it 3 times in a row. I have to write it once on the variable. I say new, I have to write it again. A little shortcut, keep hash table though. Later I say if X is an instance of a list of string to yada, blah, 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 blah. Then I got another version, because then I have to cast it. So after I say X is an instance of giant type, cast it to giant type as well. And I just see a lot of these type annotations float around. That in my head is the bulk of it.
Well, most of those are going away. So like the ones in the new call disappeared in Java 7.
Well, the generic part, I still have to say hash table. I can't say, I have a variable of type hash table, I assign it to new.
I say don't do that.
Thing.
Variables of type map, and you choose the implementation of the new site, not at the declaration site. That's a different topic.
Well, okay. I claim that's part of the same problem, right?
No, I would argue with you on that one. Anyway, and the other part about the instance of, I forget what version they've introduced it in, but you can say, if X instance of map M, now M is the right type. You don't have to say it again.
So 20 years gone by and the types we've gotten better and gotten better. Okay.
Progress is slow, but it's getting there.
Right. And there are other languages for which you can skip all that stuff always, all the time, and add it where you want it, and still get it right. Yeah, I don't know about that, Matt. I haven't done enough Swift coding. I'm curious to see. I looked at samples and examples and whatever, and it looked roughly the same, but always you get the poster child examples out of your examples, so it's hard.
So what does Swift use for type inference? Does it?
Oh, it's a classic, like Java, classic forage flow. You start from the annotations you got, and you just push it through the function you're at, and you have to re-annotate at the new function body.
Okay, cool.
It's the same as the forward flow I started with in AA. And I don't know if they do first class functions or not.
It will have a much more powerful type.
Oh, there you go. So I claim the code I saw didn't claim like this. So maybe the examples need to go. So here's an annotation. So they have a generics on there. Type inference overview. Okay, so they're claiming a Hindley-Milner with constraints. Okay, fine. So a couple other things floated out. he calls Swift a front end to LLVM. That turnaround immediately means they're not doing a jet, and they don't get the profiling feedback and so on. They have all the goodness and badnesses of LLVM. It generates decent code, especially if you give it good profiles. You typically can't unless you have a giant runtime to collect them, and it's really slow to compile. Yeah, so but maybe that's the right target for their audience too.
No.
You're
No.
deploying to mobile, it's really hard to get information back to the compiler from mobile devices.
Shouldn't be though. That seems like a path that coulda, woulda, should have been worked out eons ago. You don't get on the spot compiles necessarily, but the feedback from your program of small packets of stats should be entirely doable. I don't know, that's a different model. If you're going to have automatic upgrade of an app in the field, and the app in the field is all developed here somewhere, and it goes out and comes back and forth, and I already have a two-way pipe, the next piece of two-way pipe is stats. Fine. And building
I do hope Swift to compile fast. Please make it compile fast.
Yeah, well,
Swift.
that's what
It's
his
really
take was. It wasn't really fast compiling, so I didn't say that or excuse it or no or anything. He was like, yeah, it's not super fast.
Yeah. He'll do it eventually.
Yeah, could be. Yeah, maybe. Yeah, you at some point you get a language that's excited with lots and lots of folks. You got stability, and you can't change things, and it's much harder to make forward progress. And I get it. Java's been making amazing.
Stability is important. One of the things that's most valuable to me about Java is the Java code that I wrote in 2002 runs.
Yes. Stability is good. I get it. And typically it runs as well or better.
But their code evolution in terms of language evolution and runtime evolution isn't their best suit, I would say. But yeah, they have to make decisions. I get it.
Yeah. It's sort of, I hope to get there kind of thing, not necessarily make the same decisions, but a decade ago I wouldn't have made them either that way. But he's in a interesting spot compared to where I'm at, that's for sure. So I got no fault there.
He's a pretty cool guy. He's excellent engineer.
Yeah, the guy itself.
Yeah.
That was fun. It was a good talk. Like I said, I wish we had more time to go work on things. I think some of it was we come from such different worldviews of where we were going and where we were coming from, and our heads were so into whatever piece we're at that there was some missing context we didn't get to sort of.
We would really appreciate it if he attend a few Coffee Compiler co-op sessions.
I threw the invite out, so see what happens. I'm thinking he's a busy guy and doesn't want to do this kind of random yucky talk.
Yeah, I do realize that he stands on a few things, on a lot of things, has a real wide repercussions, and he decides when to attend and when not. Yeah.
Oh yeah. I've been in those shoes in prior times, and I get where that you pick your fights, you pick your battles.
Because in a sense he represents this language.
Yeah, right. Yeah. And Apple's sitting right there. So
yes, and taking notes and
say. That's what I'm saying. You pick your fights.
Yes.
It's all it's all good.
Okay. Yeah.
All right. It's 11:30. Any last minute questions here, or we'll wind it down?
No.
I think we should revisit, not this week, but next week, the code reloading topic. I think we only scratched the surface on that.
Yes, I believe.
Oh, yeah, we totally can. Totally.
Evolution.
Code evolution. Yeah, bring it up. Totally.
I had a lot of opinions and can make a lot of opinions.
Yeah, bring it up. All right. I'm going to call quits and then until we meet again. Bye-bye.